correct channels, at least correct privileges. And so this sharing of the data interface and the configuration interface creates a huge security vulnerability. So you can see some examples here. Ad hoc distributed queries is a functionality that should generally be turned off. In fact, I think it's turned off by default. It's used in brute forcing tools and things like SQL data thief. Should be turned off by default, can be turned on again using xp-configure. CMD shell should be turned off, can be turned on again using xp-configure. And CLR integration, which I'll get to in a minute, which is an extremely powerful feature that effectively allows us to upload and execute .NET runtime binaries, should also be turned off by default and can be turned on again using xp-configure. And so this idea of in-band signaling gives us a lot of power over a compromised SQL Server. So we've spoken a bit about in-band signaling, which is the one problem with SQL 2005. The other problem with SQL 2005 is these new features. And we're going to focus on two. One is native XML web services, and the other is CLR integration. So we'll start with native XML. Basically how it works like this is Microsoft thought it wise to make it possible to create a web service and bind it directly to a SQL procedure. Right? So now you don't need any more application layer between your web service and the SQL server. The web service's functionality can be written in and stored in SQL directly by exposing what they call an endpoint. So that any device that can parse XML and submit HTTP requests can now access a SQL server. So you look at that little diagram at the bottom, you'll see the client is connecting to the endpoint. The endpoint is basically a little XML over HTTP web service, and that endpoint can then execute raw SQL and return the results. And this is all done very, very point and click. And one of the vulnerabilities that this potentially introduces is the idea of denial of service. Because what I can now do is, if I can execute SQL, I can use T-SQL to create a web service endpoint and bind it to any location on the web server. So what you're seeing there is the web server directory on the left-hand side here. You're seeing a web server directory called test. Right? This is something that potentially is running, I can't drive my mouse so good, this is something that potentially is running on the web server. Over here you see a little snippet of SQL where I create an endpoint and bind it to test. And SQL, which is running a system, then effectively takes over that location on the web server and creates a little web service that's running there. And what you see at the bottom is the WSDL, for those of you familiar. The web service's descriptor language output for that web service. So effectively, I've created a website and overwritten any location on your web server. And the way it works is I can do that for any virtual host. So if you think to something like a virtually hosted environment where many companies have got websites running on the same server, those websites are protected from each other using file system access permissions. I can now basically overwrite any one of those websites using SQL injection, right, via any one of those websites. Does that sort of make sense? I'll show you an example now, and it'll all come together for you. So what I'm going to do is I'm going to show you how I can create an XML endpoint using SQL, and I'm going to do it using SQL injection. You see I give my endpoint a name. In this case, it's EP2. I set location, in this case, /sp. I leave the ports clear. And that's about all I need to create an endpoint. Now, what we initially set out to do is we said, well, perfect. If I can create a web service using SQL injection, then the logical thing to do is create a web service that takes arbitrary SQL and executes it and gives me the output, right? So a little SQL query engine. That would be the simplest and the easiest thing to do. But guess what? We don't even have to do that, because you see that batches equals enabled? Batches equals enabled automatically creates a web service which will take arbitrary SQL and execute it and give you the output. So I don't even have to code that. I don't have to write the procedure that will do that. Simply creating an endpoint with the attribute batches equals enabled will do that for me. So what I'm going to do is I'm going to take that SQL. You'll see it's this ugly piece of SQL over here. Anybody see my mouse? Here it is. All right, so that's a standard SQL injection. I'm executing this piece of SQL over here. I've got a little vulnerable application over there. Let's just have a look. Test and test single quote. All right, you've all seen this before. Effectively, what I'm going to do is I'm going to paste that in there. All right, so that's my SQL injection string, which is going to, let me just, before I do that, let me just show you this. This is the server that I'm compromising, SP directory. You'll see there's no SP directory there at the moment, right? Nothing. So we go back. We say test single quote. Good old OLDB provider. Drop that injection string there, and it executes. All right, so I've basically now injected the SQL to create a SQL endpoint. Check something. And if I now go back here and I hit the SP directory, you'll see I'm now asked to log in. And I can even request the WSDL. Voila. All right, so I've created, using a single SQL query, which I injected via SQL injection, I've now created a fully functional web service. And this web service, simply by having that attribute configured, will allow me to send arbitrary SQL commands. So we created a little XML client over here. It's this little thing called SQL.pl, just a cheap way to do it. There I specify the IP address of the server that I want to connect to, and there I specify the query that I want to run. And if I've done it all right, bam, there's the output, all right? And of course, because it's arbitrary SQL, I can change that into something like that. And I've got now command execution over HTTP via the SQL endpoint that I created using SQL injection. So again, sticking with my objectives that we only use the existing channels, in this case HTTP and SQL. All right, so we're starting to get a sense of the real power of this SQL Server 2005 and why this additional functionality becomes dangerous. I want to move on to the next feature quickly. Time is running a little bit out, which is this common language runtime integration. And without spending too much time on it, effectively what this means is that in SQL Server 2005, I can take any .NET bytecode, so any .NET application, and upload it directly to the SQL Server and execute it out of SQL. Now, why this is good is because previously, if I wanted to do complex things like a port scanner, I would have to code that port scanner using T-SQL. When we built Squeezer, we had a really hard time. When we built Squeezer, we had a really hard time doing that because T-SQL is not a particularly pretty language. Sorry, I've lost myself. Self. But now we can basically write it in C# or whatever the Visual C++, whatever the .NET language of your choice is. Take that binary, upload it to SQL, and execute that binary. Now, that feature should be disabled by default, right? CLR integration should be disabled by default. But luckily, via this in-band signaling, via SP configure, I can turn it on again. So if I've got SQL injection, I can turn CLR integration on, and then I can upload any .NET binary to the SQL Server and run that again using SQL injection. There's some funnies around privileges, but effectively, if I've got SA, so if my application is connecting to the database using SA, then I can make it work. Maybe just a few more steps required. So the question is, how do I take this .NET assembly, how do I take this .NET executable and get it onto the server? And effectively, I've got three choices. The first is I can compile it in place. So effectively, what you're seeing at the bottom there, where it says number 1, is a series of echo commands to construct the C# line for line. Once I've got the raw C# code on the file system, I can invoke CSC, which is at a predefined location, and compile it. And then effectively, I call this SQL command at the bottom here, create assembly. I point it to the program that I just created, and that assembly then gets loaded into SQL and can be executed via SQL. So it's cumbersome. It'll take me a long time to do it, but it's a technique, this technique of building code on a victim server, something we've been doing for a long time. Remember the upload scripts that we used to do? So we can basically use the same technique, and it will work. But it's a bit of a bore. The second technique I can use is I can create an assembly from a UNC path. So I can say, listen, fetch this binary from this place using effectively a map drive and load that. And you'll see from that little picture, basically what's happening is the database is making an outbound connection. It's fetching the DLL down and loading that into the database from where I can execute it. This is a much more elegant technique, but of course it requires outbound TCP connections, which I may or may not have, so it sort of defeats the purpose. And here comes the real sex. What I can do is using SQL, I can insert the hex-encoded binary directly into the SQL server. All right? So if I take a functioning .NET assembly, I hex-encode that, I can create that assembly on the database, basically using SQL. And what that means is I can do the whole thing purely using my existing HTTP channel if I've got something like SQL injection. So I'm going to show you quickly how that works. Right, that's me. I promised you a picture of me in my bodybuilding outfit. All right, so let's have a look over here. Right, so I've got a little executable here called socket.exe. It's that guy there. And if I encode it, you get something that looks like that. Right? That's the hex, effectively, for that little binary over there. And this, what you're seeing here, is the SQL server that we're going to compromise. I just want to show you, these are the listening ports at the moment. Right, so what I'm going to do is I'm going to use that same SQL insertion point that we had earlier. And I'm going to create an assembly directly from the hex. Okay, now that's this SQL that you see here, which I'm not going to try and type out. I'm just going to copy it straight from there. All right, so same server, same SQL injection point. Remember, we're there. Put that whole thing in there, and it executes. And effectively, using that single SQL command, I've now created that whole .NET assembly in the database, and I can now create a stored procedure from it, which is that SQL over there. Again, it looks complex, but it's surprisingly easy, and I can now execute that stored procedure, just like you would execute any other stored procedure, except remember that this is brand new functionality in the form of a .NET binary that I've just uploaded. Pop that in there. You'll see it's taking a little bit long, and the reason for that is because if I have a look here now, you'll see I've created the new listener on the victim machine. So basically, I've created a little executable that creates a listener on the Windows machine. All right, and I think that brings it to an end. The power of this thing, I think, is obvious, because effectively it means I can now upload and execute arbitrary Windows binaries inside of SQL. And where we would like to go with this, and we actually got this to work, but it's a little bit of a hassle, so I'm not going to try and show you this. But effectively, we wrote a tool called Server, which is a .NET SQL to TCP tunneling tool. I'm going to try and explain to you how it works. Again, this is the scenario. We have the SQL Server behind the firewall.